Cambridge IGCSE, October-November 2019, paper 42. Question number 1. Figure 1.1 is the top view of a rectangular paddling pool of constant depth. The pool is filled with seawater. Part A. The volume of seawater in the pool is 264 meter cube. Calculate the depth of the pool. So in this given question, the volume is given and the length of the pool and breadth of the pool is also given, and we need to find out height or depth. So here you can use the equation of volume, that is length into breadth into depth. We are provided with the values of volume, length and breadth. So in order to calculate depth, we can make depth as the subject. So we will get depth is equal to volume over length into breadth. So we can substitute the values where volume is 264 over length 44 times breadth 20. So the answer is 0.30. So depth is 0.30 meter. Part B. The mass of the seawater in the pool is 2.70 into 10 to the power 5 kilogram. Calculate the density of the seawater. Give your answer in 3 significant figures. So here we have mass and volume we have already calculated. You need to calculate density rho. So here you can use the equation of density, that is equal to mass over volume, where mass is given in this question, that is 2.70 into 10 to the power 5, and volume we have calculated in the previous section. No, volume is already given, that is 264, so we can substitute 264 and the answer is into SF 1020. As there is no decimal point, the last 0 will not count. So there is only 3 significant figures, 1, 2, 3. So the answer is in 3 significant 1020. And the unit of density, kilogram per meter cube. Part C. Calculate the pressure due to the seawater at the bottom of the pool. So here we need to calculate pressure P. So here you can use the equation of pressure in a fluid, that is P is equal to rho GH, because we have density calculated and height is nothing but depth. So we have all these value, we can directly substitute. So density we just calculated in the previous section, 1020 times G value is constant, gravitational constant 10 times H is depth, which we calculated in the first part, that is 0.30. And the answer is 3100 Pascal. This answer is in 2SF, as they didn't mention to write the answer in 2SF. Sorry, 3SF. So we can write the answer in 2SF. Part D. State a suitable instrument for measuring the dimensions given in figure 1.1. So let's look at the figure and you can see it's 44 meter, 20 meter. So we can't use a screw gauge or a meter rule. That all are for small measurements, but here 44 and 20 meters are quite big. So we can use a tape. So the answer is tape measure. Part 2. Question 2 part A. State the 2 conditions which must be true for an object to be in equilibrium. Equilibrium means balanced. There are 2 conditions for an object to be in equilibrium, and this is very, very important. A frequently asked question in many past papers. So the first condition is there should be no resultant force. So the second point is about moment, that is the sum of clockwise moment should be equal to sum of anti-clockwise moment. Instead of that, you can even write there should be no resultant moment or resultant torque or any point with similar meaning. Going to part B, figure 2.1 shows a uniform meter rule in equilibrium. The distance PQ is 100 meter. The mass of the meter rule is 0.12 kilogram and its weight is W. So there are a lot of informations given in the question. First of all, it's a uniform meter rule and it's at equilibrium. So equilibrium means we can use a concept which we have already mentioned in part A, that is sum of clockwise moments and anti-clockwise moments will be equal. And from this uniform meter rule, we can understand that its weight will act exactly at the center. And it's given 100 centimeter is the length of PQ. That means from P to Q, that is the total length is 100 centimeter and its mass is 0.12 kg and weight is represented by W. Part I. On figure 2.1, draw and label. First one, an arrow to show the force W, that is nothing but weight, which is already mentioned, acting on PQ at the center of mass. So since it is a uniform meter rule, its center of mass will be exactly at the center, and center will be half of 100 meter, that will be 50 meter away. So this is the center. And weight will be acting always downwards. So see here, it's 10 centimeter plus 40 centimeter, total a 50 centimeter, that is this position. So the weight will be acting downwards. 2. An arrow to show the force R acting on PQ at pivot. So the force R acting on the pivot. Let's look at the figure again. This is pivot, and at the pivot there will be supporting force, that is normal reaction force, and this reaction force will be always perpendicular to the surface and it will be upward. So this is reaction force. Okay. Part 2. By taking moments about the pivot, calculate force F. So we have now consider pivot. About pivot, by considering moments, we need to calculate this unknown force F, which is acting upward or anti-clockwise direction at Q. So here you can use the concept of equilibrium. As this bar is in equilibrium, the total sum of clockwise moments will be equal to anti-clockwise moments. So let's find which all forces, how many forces are there, and which all forces are causing a clockwise and anti-clockwise moment. As we are taking the moment from this pivot, we don't need to consider this reaction force because which is acting exactly on pivot. So the distance is 0. So the normal reaction force, since it is acting on the pivot, it does not cause any moment. So only 3 forces causing moment. The first one is the 50 Newton force, which is acting at P, and let's see which will cause this meter rule to rotate in this direction, that is anti-clockwise. So the force 0.50 Newton will cause this meter rule a moment in anti-clockwise direction as shown in the figure. And the second force is its weight. Weight will cause this meter rule to rotate in this given direction, which is clockwise direction. And the third, which is the unknown force, which is acting upward force, which will cause this meter rule to rotate in this direction, which is again anti-clockwise. So here basically 3 forces where this 0.50 Newton at P and this unknown force F are causing anti-clockwise moment, where weight is causing a clockwise moment. And as mass is given, you can calculate weights using the equation W is equal to mg. Mass of the meter rule is 0.12 times g is gravitational constant 10. So you will get 1.2 Newton, that is the weight. So we can go to the question, and first of all we can write the condition for equilibrium, that is total clockwise moment is equal to total anti-clockwise moment about the point pivot. So here the clockwise moment is only caused by weight, So the equation of moment is force into distance. So we can write weight into distance from the pivot. So let's look at the figure, and from pivot to the point where the weight acts, the distance is given, that is 40 centimeter. So we can use here distance as 40 centimeters. So you should multiply into 10 to the power minus 2 in order to convert it into meter, or you can ignore because all the values are given in centimeter. So we will have 10 to the power minus 2 at both the sides, so it will automatically get cancelled. So that is equal to total anti-clockwise moment. So here anti-clockwise, the first one is due to 0.50 Newton, and which is, again by looking at the figure we can identify, which is 10 centimeter away from the pivot. So we can write the 0.50 Newton times the distance is 10 centimeter. So 10 plus there is one more force which is causing anti-clockwise, that is this, the final force which we have to calculate. So that force, unknown force, times the distance from the pivot is again from this, we need to calculate. This is pivot, from pivot to Q where F acts. The total distance is, from pivot to the center it's 40. From center to Q again 50. So the total will be 90 centimeter. So F times 90, because F is 90 centimeter away from the pivot. And weight also we have calculated using mg 1.2. So we can substitute that also here. So 1.2 times 40 is equal to 0.50 times 10 plus F into 90. So we will get 48 is equal to 5 plus 90F. So 48 minus, we can take 5 to the other side, will be 90F. So 48 minus 5 is 43 is equal to 90F. So F will be, we can take 90 also to this side. So we will get 43 over 90 is equal to F, and that is 0.48 Newton. And please note that it is 4-mark question. If you know the concept, it is very easy to solve this question. And please don't forget to write this total clockwise moment is equal to total anti-clockwise moment, and by identifying each moment you will get marks. And you should write the final answer into SF with the unit in order to score full mark. Part 2, calculate R, the reaction force. So here we can use, now we have basically in this figure 4 forces are acting. First force is 0.50 Newton downwards, and weight is also acting downwards. Then the third force just now we have calculated in the previous part, F, and there is a normal reaction force which is acting upwards. In this question you need to calculate R. We already have W using mg, it's 1.2 Newton, and force F we have calculated 0.48 Newton. Now the only unknown force is reaction force R. Using the first condition of equilibrium, we can find the answer of R, that is the total upward force must be equal to total downward force, where normal reaction force and force F are upwards. So this sum must be equal to the sum of 0.50 Newton plus W, that is weight. So first we can write the equation, upward forces must be equal to downward forces as it is in equilibrium. This is one condition. So upward forces are reaction force plus force F must be is equal to the downward forces are 0.50 Newton plus the weight 1.2. where F also we have calculated in the previous section, that is 0.48 is equal to 0.50 plus 1.2. So R is equal to, we can take 0.48 to the other side. So 0.50 plus 1.2 is already there. That answer you should minus with 0.48. So we will get 1.7 minus 0.48. So 1.2 is the answer. So 1.2 Newton. Question number 3. Figure 3.1 shows a gas contained in a cylinder enclosed by a piston. So we have a cylinder which consists of some gas and which is enclosed by a piston. Describe in terms of momentum of the molecules how the pressure is exerted on the walls of the cylinder. So here you should include 3 main points. The first point, how this molecule will cause a pressure on the wall. The reason is these molecules will collide. As they are moving random direction, they will collide frequently with walls. They are moving randomly, but when they reaches at the wall, they will collide. So this is the first reason we should write, that the molecules collide with walls. So when they collide, what happen? Initially, look at one example here. Suppose one particle, when it is moving in this direction, the moment it collides with the wall, its direction will change. Its direction changes means its momentum will change, because momentum is a vector quantity. So after collision, the particle's direction will change. So definitely its momentum will change. So if there is a change in momentum, definitely there must be a force. Whenever there is a force, there will be a change in momentum. This relation we can use here. So very important point. This change in momentum, as the direction changes when it's collide, causes force on the walls. So now there are forces acting on the wall. If there is a force, there will be definitely pressure, because pressure is equal to force over area, or in words you can write force over area. So pressure is exerted. So these points you should study well, and if you write these points only, you can score 3 marks. So initially there is a change in momentum. Initially these molecules collide with the walls, which will cause a change in momentum. When there is a change in momentum, it definitely means it exerts a force. When there is a force, then definitely if there is a force acting on an area, it will cause pressure. So these are the points you should write. And this is also a frequently asked question. Part B. The piston is pushed into the cylinder. The volume decreases from 820 cm cube to 330 cm cube. The pressure gauge measures the pressure after compression as 20,000 Pascal. The temperature remains constant. Calculate the value of pressure before gas was compressed. So now the volume decreased. Initial volume we can represent it with V1, and final volume, decreased volume when the piston pressed, is V2, and when the volume decreased, the pressure increased. So the new pressure is P2. We need to calculate the initial pressure, P1. So here you can use the equation P1 V1 is equal to P2 V2. This is Boyle's law. Now we have the values. We can substitute P1, which we need to calculate, but V1 we have. Initial volume was 820. As at both sides there is volume, which both are in centimeter cube, we don't have to convert to meter cube because it will automatically get cancelled. And the other side, P2 is 20,000 times V2 is the new volume 330. So P1 is 20,000 times 330. We can take 820 to the other side. So we will get 8,000 Pascal. So 8,000 Pascal is the answer. Question 4. A student carries out an experiment to determine the thermal capacity of a metal block. The block is heated by an electric heater for 23 minutes. The current in the heater is 3 ampere at a potential difference of 12 volts. The temperature of block rises from 20 degrees Celsius to 70 degrees Celsius. Calculate thermal capacity of the block. So here we need to calculate thermal capacity C. Let's see which all values we have. We have time, we have current I, we have we have voltage, potential difference V, and delta T, temperature change also we have. So the equation of specific heat capacity C is equal to E over delta T, energy over change in temperature. We have delta T but we don't have E, but we can use the equation of E, that is, so here we can use the equation power is equal to energy over time. From these, energy is power times time, where power is product of voltage and current. So instead of power we can write VIT. So we can use this equation. Energy is the product of voltage, current and time here. So instead of energy we can write VI times T over change in temperature. Now we have all the values. Voltage is 12, current is 3 ampere and time is 23 minutes. So 23 minutes into seconds, 23 into 60 divided by change in temperature, that is 70 minus 20. And the answer is 990 into SF. So 990 with the unit joule per degree Celsius. If you have confusion with the unit, look at the equation. So specific heat capacity, energy over temperature. So the unit of energy, joule over temperature unit, degree Celsius. Part B. Two metal spheres of different diameters are heated to 900 degrees Celsius in a hot oven. The two spheres are removed from the oven. So both are metal spheres but the diameter is different. Diameter is different means size is different. State and explain any difference in the initial rates of emission of radiation of thermal energy between the two spheres. So basically we have two spheres. One is small diameter and another one is with large diameter. So the sphere with large diameter will have larger surface area. So more area to emit heat or radiation. So more amount of thermal energy will be lost. So we can write down larger sphere emits more thermal energy because of greater surface area. Here this area is very important and you should mention large sphere emits more thermal energy. 2. One hot sphere is now heated in a hotter oven. State and explain any effect on the rate of emission of radiation of thermal energy from that sphere when it is removed from the hotter oven. So now the sphere was already hot and additionally we have kept it in a hot oven. So the temperature of the sphere will be even more than the initial case. So more temperature, and when you take it out, it will radiate more heat. So we can write down greater rate of radiation and you will get 1 mark. So the total 3 marks for part B. Question 5 is from the topic waves. Part A. One difference between a longitudinal wave and a transverse wave is that a longitudinal wave consists of compressions and rarefactions. Explain the terms compression and rarefaction using ideas about particles. So the region in a wave where the particles are close together is known as compression, but the region where the particles are far apart, as you can see, are known as rarefactions. So for compression we can write particles are closer. For rarefaction, particles further apart. Since it is 2 mark question, you just need to write only 2 points. Part 2. Describe one other way in which longitudinal wave motion differs from transverse wave motion. So already one way is mentioned in the first part in terms of compressions and rarefaction. Other than that, using another concept or other way, we should differentiate longitudinal and transverse waves. So here we can use the definition of longitudinal and transverse wave, or how the particles move compared with the direction of the propagation of the wave. So here we can write longitudinal waves in which the vibration of particles are parallel to the direction of wave motion. But for transverse wave, it is perpendicular. So we can write vibration of the particles are perpendicular to the direction of wave motion. Going to part B. A sound wave of frequency 0.120 kHz travels through a rock at speed of 3500 meters per second. Calculate the wavelength of the wave. So we need to calculate wavelength lambda, frequency and speed is given. So here we can use the wave equation, that is speed of a wave is the product of frequency and wavelength. And in order to calculate wavelength, we can make wavelength as a subject. So we will get wavelength is speed over frequency, where speed is 3500 times frequency is 0.120 kilohertz, that is 10 to the power 3. And we will get 29. So wavelength is 29 and the unit of wavelength is meter. Part 2. The wave travels from the rock into air. State and explain whether the wave will be audible to healthy human ear. So here the wave is moving from a rock to air. So when the wave moves from rock to air, there will be a bending. The wave will bend, and since it is from denser to rarer, it will bend away from the normal. But we don't need to know more about this. But we should understand when the waves moves from one medium to another medium, its frequency is not going to change. Frequency will be always constant. So its frequency will be same as given, 0.120 kilohertz. So frequency of this wave is 0.120 kilohertz. Kilo means 10 to the power 3. That is 0.120 into 10 to the power 3 hertz. So we will get 120 hertz. Now let's check this sound wave with the frequency range 120 is audible. So the audible range of sound wave is from 20 hertz to in between 20 hertz to 20 kilohertz. And we have a sound wave with a frequency 120 hertz, and definitely this range or this value is in the audible range, so it can be heard. So the statement about the wave when it is moving from one medium to another medium, that is from rock to air, we can write frequency not changed. First of all, sorry, for the statement we can write it will be audible. Yes, it will be audible, but for the explanation we can write frequency not changed. Question 6. Part A. Figure 6.1 shows an empty container and an observer's eye. There is a small coin at position O. The observer is unable to see the coin. The observer and the coin stay in the same position and the container is filled with water. The observer can now see the coin. Part 1. Explain why the coin can be seen by the observer. So here the reason is, when the container filled with water, the light wave which is coming from the coin, when it reaches at the boundary between water and air, it will bend away, more away, because of refraction. Since the light wave is moving from denser medium to rarer medium, it will move further away from the normal, so that the observer can see now. So here we can write light from, so the first point, light from coin to air will get refracted. And how it will get refracted? It will bend towards the normal or away the normal. That also we can mention. The light wave bent away from the normal. And it's because the light wave is traveling from a denser medium to rarer, where water is denser and air is a rarer medium. Part 2. State the name of the wave process which occurs as the light passes from water into the air. We have already discussed, when the light waves travel from one medium to another medium, refraction will occur. That is the bending of the light wave. So we can write refraction. Explain why the image of the coin is a virtual image. So we know clearly that these are the observer can see the coin now only because the light waves are bending. It's not straight wave from the object. So we can write that point. Rays do not originate from image, or they only appear to come from the image. You can write any point. Part B. State the speed of light in air, which is constant value, and that is 3 into 10 to the power 8 meter per second. Part C. Refractive index of water is 1.3. So refractive index n is given. Calculate the speed of light in water. So here we can use the equation refractive index is equal to speed of light in air over speed of light in water. In order to calculate refractive index of water, we can make refractive index of water as a subject. So we will get speed of, in order to calculate speed of light in water, we can make it as the subject. So speed of light in water is equal to speed of light in air over refractive index of water. So we can substitute speed of light in air is 3 into 10 to the power 8 over refractive index is given 1.3, and the answer is 2.3 into 10 to the power 8 meter per second. Part 7. Question 7. Figure 7.1 shows a coil of wire wound on a thin plastic cylinder. The plastic has no effect on any magnetic field. The galvanometer is extremely sensitive. A magnet is fixed to a small trolley that runs without friction on a track through the cylinder and coil. So the figure consists of a coil. This is a coil which is wound on a plastic cylinder, as you can see. And there is another magnetic bar on a trolley, and this trolley is free to move as there is no friction. The coil is connected to a galvanometer which is very sensitive. That means even for a small amount of current variation, it will clearly show in the galvanometer. Part 1. The trolley is released from A, so it runs through the coil from right to left. State and explain what is observed on the galvanometer. So let's look at this figure again. We have the magnet. As it is a magnet, there will be magnetic field line around the magnet pointing from north pole to south pole. When the trolley released, the trolley will be move freely through this inside the coil. So when it is moving, these magnetic field lines will be linked with this coil, and this magnet will continue to move towards the other end. The field lines will get cut by the coil. So now we have a coil, and the field lines, magnetic field lines or magnetic flux is getting cut continuously by this coil. So there will be electromagnetic induction, and there will be a current flowing through the coil. So this coil, it will conduct a current, induced current due to electromagnetic induction or due to the magnetic field lines get cut by the coil. So the galvanometer will deflect, or it will show a reading because of the flow of current. This is what we can observe. So state and explain what is observed on the galvanometer. So we can write, we can observe a deflection on the galvanometer, and for a short time, only during the time when this trolley is passing inside the coil. So we can write deflection for shorter time. Part 2. The trolley is now released from point B. So it runs through the coil from right to left again. State what is observed on the galvanometer and explain why it is different to your answer in A. So initially the trolley was kept at A, and when it released, we have seen there will be a small current passing through the coil, so that there will be a deflection in the galvanometer. But instead of A, if the initial position of the magnet is B, in second trial, what you can observe? Will it be same or not? So we should understand, when the trolley now at B, it is having more potential energy as it's more higher. So when it is passing through this coil, it will have a higher speed. When the speed is more, the amount of current generated will also be small, will be great. I will repeat, when the magnet starts to move from position B, initially it will have a greater potential energy, so it will have a more speed while it is passing through the coil. When speed increases, the induced current generated will also increase, so there will be a greater deflection. So we can write down, larger deflection we can observe due to higher speed. So 1 mark belongs to larger deflection and the second mark for high speed. Part B. Figure 7.2 shows an extension lead used to supply power to a 3 kilowatt electric heater on a cool evening. So we can see there is damp grass and a 3 kilowatt electric heater kept, and to connect the extension there is a plug and socket which is also lying on the grass, and the extension lead is there. This lead is designed for 25 watt lamp. State and explain 3 dangers with this arrangement. So let's look at the figure and we can understand that the plug and socket kept simply on the grass, and the grass can be wet. And another danger you can see, cut in outer insulation. There is a cut in the outer insulation. It can also cause so many dangers. So we can write point by point. The danger 1, socket on wet grass. Second one, short circuit through cut in insulation. And the other one, shock or again short circuit through plug on this wet grass. Since it is a 4 mark question, we need to write 4 points. So first point written, danger 1. it's incomplete. When the current is too high, trip hazard can occur in the cut in insulation. We have seen there is one small cut in the insulation. And when the socket is on the wet grass. So you will get 2 marks for this statement and explanation. Question number 8, part A. A wire of length 2 meter and cross-sectional area 0.40 millimeter square has a resistance of 0.14 ohm. Calculate the resistance of another wire of the same material of length 3 meter and cross-sectional area 0.90 millimeter square. So here initially we have a wire of 2 meter length and which is having a cross-sectional area of 0.40 millimeter square and its resistance is given, that is 0.14 ohm. But the same material used to make this wire has used for another wire with a length, instead of 2, now it has increased to 3 meter, and its cross-sectional area also increased from 0.40 to now new cross-sectional area is 0.90 millimeter square. So both the length and area of cross-section has increased. So what will be the new resistance? For the second wire, we need to calculate the resistance. So here you can use the relation, that is resistance is proportional to the length and resistance is inversely proportional to the area of cross section. That means when the length of the wire increases, resistance of the wire will always increase, and when the area of cross section of the wire increases, resistance will decrease. This is an important relationship we should always remember while doing the question based on the concept resistance and resistivity. Now we can check the new length from 2 to 3, how much has changed. So we just need to find the ratio. So the ratio in the change in length is 3/2. That is the new length over the old length. Likewise, change in cross section is 0.90/0.40. So comparing to the old length, the new length is this much changed and 3/2 times greater. Likewise, the area of cross section also changed to this ratio. Now we can substitute in the relation, that is new resistance will be the old resistance times, since length is directly proportional, we can simply multiply directly the change happened to the length times the area of cross section is inversely proportional. So we have to take the inverse of the change happened to the area of cross section. So inverse of 0.90 over 0.40 will be 0.40 over 0.90. Answer is 0.093 ohm. So we can write 0.093 ohm is the new resistance. Here the resistance has reduced as the area of cross section has changed more. Part B, a student is designing a digital electronic circuit. Looking at the circuit, we can understand there is one NOR gate and one AND gate. Let's look at the truth tables of NOR gate and AND gate separately. So for NOR gate, when the inputs are 0, 0, the output will be 1, and when it is 0, 1, output will be 0. When it 1, 0, output will be 0. When it is 1, 1, output will be 0 again. Likewise for AND gate, when the inputs at 0, 0, the output will be 0. When input is 0, 1, the output will be 0 again. When the input is 1, 0, the output will be 0. When the input is 1, 1, the output will be 1. Now let us look at the truth table. Here input at A is 1 and the output at point C is 0. So let's check. At A the input is 1, at B we don't know, but at C we are getting 0. So here we are getting 0. So let's look at the truth table of NOR gate. This one is NOR gate. So we should get input at A is 1. So we have this two options, and B input we don't know, but the output we should get 0. So here these both options can be correct. So the input at B can be either 0 or 1. We don't know which one is, because according to the truth table, input at B can be 0 or 1. So let's look at the output at D. Output at D for these values is 0. So here we are getting an output that is 0. So let's look at the AND gate truth table. So input at A is 1. Okay, either this or this. And output of AND gate is 0. So here its only option is this. In order to get an AND gate output is 0, where A input value at A is 1 is only 0. So the input at B should be 0. So here the only possible value is 0 at B. So we will get these outputs. Let's look at the second row. In second row we have input at A is 0 and input at B we have no idea, we need to calculate, and the output at point C is 0 again. So we have already seen the truth table of NOR gate where this possibility, where the input at point A is 0 and output is 0 is only this. So definitely the input at point B should be 1 in order to get a 0 output when input A is 0. So the input at B must be 1 in order to get a 0 output at C for a NOR gate. So we can fill the table that input at B must be 1. So let's check for the same value for same row, the output at D is correct. So let's look at the truth table and we have 0 at A and 1 at B. So looking at the truth table of AND, 0 and 1, we are supposed to get 0 output. So let's check. Yes, we are getting 0 at point D. It's already mentioned in the truth table. So that value is also correct. Now we can check the third row where input at A is 1 and output at point C is 0. So at A input is 1 and output at C is 0 and output at D is 1. So let's check the truth tables and which value should be at B is possible. So first let's look at this NOR gate. We need 1 at the input A and at output we should get 0. So again two values are possible. So we can look at the AND gate. So in AND gate, input value at A is 1 and output also we should get 1. So let's check which is the possible value for AND gate, as we should get both input and output as 1. For an AND gate, the B input also supposed to be 1. So the correct answer must be 1 here. So when 1 at A and B, we will get outputs 0 at C and 1 at D. So this value also 0. Now the last row, let's check the values. At input at A is 0 and output values at C is 1 and D is 0. So 0 at A and 1 at C and 0 at D. So let's again look at the truth tables. So first we can consider the NOR gate, and we need to check when input is 1, input at A is 0 and the output should be 1. So that is, there is only one option, that is a first row in the truth table, where we can see when 0 at A and B only we will get 1 as the output of a NOR gate. That means here the value must be 1. So we can complete the table that input at B also must be 1. Next, part 2. The column O in the truth table shows the desired output values for the circuit. On figure 8.1, complete the circuit to achieve these output values. Label any gate used. So looking back to the circuit, it's clear that this part is not available. So we have to fix a gate here as mentioned, label any gate used, in order to get an output of these values. From these two values, you should get an output 1, 1, 0, 0. So let's check which table we should use. When 0, 0 is the output, we should get 1. So same value for the second row also. And when 0, 1, we should get 0. When the input are 1, 0, we should get 0 again at the output. So this is the table or truth table of a NOR gate. As you can see, when 0, 0, we will get output 1. When 1, 0 or 0, 1, we will get output 0. So in order to get an output as given at O, we can simply fix a NOR gate because it's doing the function of a NOR gate. So you should keep a NOR gate between here. So that's it. Question number 9. It's from the chapter electric field. Part A, describe what is meant by term electric field. So it's a very important question. A frequently asked definition you must study. So field means region or space. So we can write it is the region where what happen in an electric field. A electric charge will experience a force. So here all these words are keywords, the region where an electric charge will experience a force. You must include all these keywords in order to score 1 mark. Part B. Figure 9.1 shows two parallel conducting plates connected to a battery. So we have two conducting plates which is connected to a battery as shown in the figure. On figure 9.1, draw 5 lines to show an electric field pattern between the two plates. So since it is parallel uniform plates, the field lines will be parallel, straight lines, but the direction is important. So in electric field, the field lines will always point from a positive side to negative side. This is very important. So let's look at the given figure where which plate is positive and which plate is negative. So we can see the plate connected to the negative terminal of the cell will be negatively charged. So we can understand this plate at the right side is negative and the plate at the left side, which is connected to the positive side of the battery, will be positive. So we can draw field lines. So here we should draw minimum 5 parallel lines with equal spacing. That is also important. You can take the ruler and take the measurements. And don't forget to put the arrows. It should always from positive to negative as we mentioned. This arrow is also important, and straight lines should be equally spaced as the electric field strength will be uniform in between the plates at all the points. Part C. When fully charged, a 1.2 volt rechargeable battery can deliver a current of 210 milliampere for 10 hours. Calculate the charge that can be delivered by the fully charged battery. So we are provided with the voltage here, current and time. Then we need to calculate charge Q. So let's see which equation relates charge and these given values. So we know that current I is Q over T. By rearranging, we can write down charge is the product of current and time. So we have both the values. Current is 210 milliampere. So 210 milli, we should convert milliampere to ampere. So milli means 10 to the power minus 3. So we can substitute instead of milli 10 to the power minus 3 times time is 10 hours. Hours we should convert into seconds. So 10 hours into minute multiplied by 60 and minutes into seconds again we need to multiply it with 60. And the answer is 7600. Unit of charge is coulomb. So C. So the answer is 7600 coulombs. Part 2. Calculate the energy stored in the battery. So here we need to calculate energy. Here we can use the definition of the equation of voltage, as voltage is the work done over charge or energy over charge. From this we can rearrange, so we will get energy is voltage or potential difference times charge, where voltage is already given, that is 1.2, and charge we have already calculated 7560 when it is in 3SF. So the answer is 9100 joules into SF. Part 3. State the type of energy stored when the battery is charged. Chemical energy. Always in a battery, the energy stored in the form of chemical energy. Going to the last question. Question 10 part A. The nucleus of a hydrogen atom is a proton. The mass of proton is m and the size of the charge on a proton is E. Complete the table 10.1. Express your answers in terms of m and E. 3 spaces have already been completed. So we have the particle or emission of a proton and its mass is m and its charge is E, which is already mentioned. And if we have neutron, the mass of neutron is same as the mass of a proton. So we can use the symbol m. What is the charge of a neutron? So we know that the neutron has no charge, so we can write 0. Next one is a gamma ray. As the name indicates, it's simply a ray, not a particle, so it has no mass. So the mass is 0 and charge also 0. It's simply an electromagnetic wave. So the charge and mass is 0. Only the speciality of gamma ray is it is having very high frequency. So high energy. Now going to last row, nucleus of helium-4. So we know that helium-24 is the symbol. That means it consists of 2 protons and 2 neutrons. So helium nucleus consists of 2 protons and 2 neutrons. So let's look at the mass. We know that proton and neutrons are heavy and their mass is represented by m. So 2 protons mean 2 times m and 2 neutrons means 2 times m plus 2 protons means again 2 times m, because both protons and neutrons are having a mass m. So we will get 2m plus 2m, mass of protons plus mass of neutrons, so 4m. So 4m is the mass of helium nucleus as it consists of 2 protons and 2 neutrons, and charge. And charge is contributed only by protons because neutron has 0 charge, and 2 protons will give 2 E's, as 1 proton is having a charge of E. So there are 2 protons, so E plus E. So we will get 2E. So that is the charge of a nucleus of helium atom. Last question. Part B. Many schools and colleges use radioactive isotopes for teaching and research. Describe how these radioactive isotopes are handled, used and stored in a safe way. So there are so many different ways, but it's only 3-mark question, so we need to write any 3 points. So handle using tongues and gloves or by wearing a protective clothing. Third point, minimize the exposure with these radioactive elements. So minimize the exposure by time. Use a shielded storage. So we have already written 4 points. 3 points are enough. So thank you for watching the video. If you find this video useful, please like the video and subscribe my channel. Thank you.